Day 3 is going to be about algebraic fractions. This is a really tricky topic, so you need to make sure that you are really trying your hardest with this. And if you didn't follow something I said, rewind it and rewatch it until you truly get it, okay? So topic A is going to be about when fractions are undefined, which should be a little bit of a review for you already. But just so that you guys know, if you divide a fraction by 0, the fraction will always be undefined, okay? And the reason why is because when you divide numbers by smaller and smaller numbers, for example, if you take 5 divided by 1, you end up getting 5, right? If you take 5 and divide it by 1/2, it ends up being 10, it gets bigger. If you take 5 and divide it by 1/4, ends up being 20, right? So the smaller the number is in the denominator, the higher this number is right here. And when you approach 0, the answer will approach infinity, okay? So it's because it approaches infinity, which is a number that we don't know, right? It's not an actually defined number, all right? So for the following questions, determine all the values of x for which the fraction is undefined. So basically, I just want to know, when is the denominator equal to 0? So all I have to do is just basically divide everything through, basically set each denominator equal to 0. So in this first example, the denominator is 2x. So you're just going to type in 2x, or write down 2x equals 0. Please do not write it up here, because that is not really valid. It's not helpful. Just rewrite the equation out and say 2x equals 0, solve for x. This is nice and easy. You end up getting x equals 0. So it's undefined when x equals 0. Okay? And number 2, I'm going to set the whole denominator equal to 0 again. So x squared plus 7x plus 6 equals 0. Now remember, this is a quadratic equation. So to solve a quadratic equation, you need to factor it. Nice thing is the leading coefficient is 1, so this will be x, this will be x. I'm going to look for two numbers that multiply together to give me 6. My options are 1 and 6, or 2 and 3. I'm going to choose 1 and 6 because I want this 7 right here. So x plus 1, x plus 6, set each part equal to 0. Hopefully you remember this stuff. So you end up getting x equals -1 and x equals -6. And that's basically all you have to do when you have undefined fractions. All right, topic B, steps to simplifying fractions. That's what we're going to be talking about next. So how do you simplify an algebraic fraction? So the first thing you're going to always do is you are going to factor the numerator and the denominator if possible. Okay, so we're going to say that we are going to factor the numerator and the denominator. And then you're allowed to cancel terms only if they are factors. Okay, so for example, if you have 4/8, that reduces to 1/2, but the reason why you're allowed to do that is because it's really technically 4 times 1 over 4 times 2. These are factors because they're multiplication, right? Factors mean they're numbers that multiply together, so that's how you end up getting a 1/2. Okay, so we're going to do something very similar with this example right here. So in number 1, you have 12 over 18, right? So you can reduce this, all right? And I can say that this 12 can become a 2, and this 18 can become a 3 because they're both divisible by 6, okay? And then I'm going to look at the x squared and the x. There's more x's on the top than there are on the bottom. One of these x's completely goes away, and I have an x left over on top. Okay, then I'm going to look at the y's, and for the y's, I have 1 y on the top and 3 y's being multiplied together on the bottom. So one of these y's cancels out, and then I have 2 y's left over right here. So this ends up becoming y squared. Okay, so this right here is y squared, so that means simplified, I get 2x over 3y squared. When you are done, you have to ask yourself, is there anything in common with numerator and denominator? If there isn't, then you are good to go. Okay, now notice how I didn't have to factor number 1 because it's already all being multiplied together. It's 12 times x squared times y over 18 times x times y cubed. Okay, but let's take a look at question number 2. In question number 2, you have things being added and things being subtracted in the numerator and things being subtracted in the denominator, and that is not possible to cancel, because again, the only way you can do it is if they are factors. Again, that is crucial. So a lot of people will try to take this A and cancel them out, and that is illegal, completely not allowed, because this is a package deal. So the only way, again, you can cancel stuff out is if they are factors. But the good news is that I can factor it. So look at the numerator in question number 2. The first question you always ask yourself is there a GCF? And there is. There's a B in common. So I'm going to factor out that B. Okay? So I'm going to say B times, and then when I factor out the B from this AB right here, I end up getting A. And then when I factor out the B from this B squared, I end up getting B. So it's B times A minus B. All right. Over, before I move on, I'm going to ask myself, is there any more factoring I can do? So look at what's inside of here. You've got A minus B. There's nothing in common with A minus B. It's not a trinomial, so you can't factor it as a trinomial. It's not a difference of perfect squares. It's not a perfect square trinomial. So you've basically factored it as far as you can. So this is good to go in the numerator. So in the denominator, the first question you're going to ask yourself again is there a GCF? And there is. There's a 5 in common, and there's also an A in common. So I'm going to factor out 5A. All right. Now when I divide this 5A squared by 5A, I have an A left over. Okay. And when I divide this 5AB by 5A, the 5 cancels, the A cancels, so I just have a minus B left over. Notice how I now have factors. It's B times A minus B and 5A times A minus B. So I'm allowed to get rid of this factor with this factor. They completely cancel out. So my final answer is B over 5A. Okay. So I'm going to have you look at question number 3 with me. In number 3, I'm going to see if I can do any factoring at all. So in the numerator, I'm going to ask myself, is there a GCF? Is there anything in common with the x squared, the 2x, the negative 2x, and the negative 3? There isn't. So then the next question I'm going to ask myself is it a difference of perfect squares? It's not, because it's not even a binomial, and negative 2x is not a perfect square, and negative 3 is not a perfect square. Okay? Lastly, I'm going to ask, the third question I'm going to ask myself is, can I factor it either by trial and error or by grouping? Is it a product of 2 binomials, basically? And it is. Okay? So if I were to factor this, I know that I'm going to have 2 sets of parentheses. Again, leading coefficient is 1, so it's nice and easy. So I'm going to have an x here, an x there. Okay? And then I've got 2 numbers that multiply together to give me negative 3. And my only options are 3 and 1. And I want it to add up to give me negative 2. So I'm going to say x minus 3 and x plus 1, because negative 3 times 1 is negative 3, and negative 3 plus 1 is the negative 2 I'm looking for. Okay? And the numerator is completely factored. Now let's look at the denominator. In my denominator, I've got x squared minus 5x plus 6. Okay? There is no GCF, so it's not a GCF question. It's not a binomial, so it's not a difference of perfect squares. It appears to be a trial and error problem, or a grouping problem, whatever you prefer again. And the leading coefficient is 1 again. Nice and easy, x and x. I'm going to look for 2 numbers that multiply together to give me 6, but add up to give me negative 5. So think about that for a minute. Hopefully you got negative 3 and negative 2. Okay? Now notice we've got 2 factors on top and 2 factors on the bottom. So I end up getting x minus 3 can cancel out with x minus 3. So I end up getting as my final answer x plus 1 over x minus 2. Now a lot of people will try to cancel out this x with this x, but that is not allowed, because this x and this 1 are not factors, so you're not allowed to get rid of the x with the 1. You're going to treat it like a big happy family, and you don't want to take a member of the family out. Okay, so that is not allowed at all. This right here is my final answer. Okay, and then last one of simplifying fractions. Question number 4, I'm going to look at the numerator. There's no GCF. It's not a difference of perfect squares. It's not a trinomial, so I can't put it as a product of two binomials together, so it's not really factorable, okay? So I'm going to copy it down. X plus 3 stays in the numerator. In the denominator, there's no GCF. It is a difference of perfect squares because it's a binomial. There's subtraction, and x squared and 9 are both perfect squares. So that means that I end up getting x plus 3 times x minus 3 in the denominator. Now, a very common mistake that people will make, well, first of all, the x plus 3's cancel out. A common mistake that people will make is that they'll think the answer is x minus 3. But that's actually wrong because this x minus 3 is in the denominator. Keep it in the denominator. It's not allowed to go into the numerator, okay? And then a lot of people will think to put a 0 here, but that is also wrong because when we divide things out, anything divided by itself will never be 0. It will always be 1. So that means that the 0 can't be on top. It's 1 over x minus 3, okay? Hopefully that makes sense to you.